Question 6. The first three terms of an arithmetic progression are p squared over 6, and the next term is 2p minus 6, and the last term is p. Given that the common difference of the progression is not 0, find the value of p. So first step, we know that the arithmetic nth term is equal to the first term plus, in the brackets, n minus 1 multiplied by d, right? So let's say if we are trying to find the last term here, the third term, so this one is n equal to 1 to 2 to 3, right? So the last term is when n is equal to 3. So the last term here is p, and the first term is p squared over 6 plus n, which is 3 minus 1 d. 3 minus 1 is 2, so we'll have 2d. Let me remove that and write it down properly. 2d. So next, I will try to rearrange the equation in the way that d is equal to something. So what I can do is I can minus this term, the p squared over 6, on the left hand side, and it will be gone from the right hand side, right? And then I will divide the whole equation by 2, so that we'll have p over 2 minus p squared over 12 is equal to d. Now that will be our first equation. And the second equation would be calculated based on the second term here. So using the same nth term formula, 2p minus 6 will be equal to the first term, which is p squared over 6, plus 2 minus 1 d, because this is the second term, right? So it's 2 minus 1 d. And we know that 2 minus 1 is 1, so it's just 1d, right? Again, we'll try to rearrange the equation so that d is being left alone on the other side. So I will minus the left hand side with p squared over 6, and the p squared over 6 on the right hand side will also be gone, and then the right hand side will be left with d. And that is our second equation, right? So next, what we can do is simultaneous equation solving. We can set the d from equation 1 to be equal to the d from equation 2, which is p over 2 minus p squared over 12 is equal to 2p minus 6 minus p squared over 6, right? So the equation again looks kind of tricky to solve. So what we can do is we can multiply the whole equation with 12, so we can get rid of all the denominators. So I'm going to multiply the whole equation by 12, and now we'll get 6p minus p squared equals 24p minus 72 minus 2p squared. If I plus 2p squared on both hand sides, I will have, this one will have p squared, right? I'm trying to get rid of this one. And if I deduct 24p from this side, on the left hand side will be minus 18p. And if I plus this 72 here on the left hand side, there you go. And then we can do factorization, or we can also put this equation into the calculator. So I will just go with the factorization, and we'll have p minus 6 multiplied by p minus 12 here equals to 0. And we'll have either p is equal to 6 or p is equal to 12. So now we'll have p minus 6 is equal to 0. So p is equal to 6, or p minus 12 is equal to 0. So we'll have p equal to 12. That's another possible answer. Right? So let's try plugging in our answers. So if d is equal to, let's use this equation, the first equation. D is equal to p over 2 minus p squared over 12, right? So we're going to plug in p there. So it's 6 minus 6 squared. And we will have 0. So d is not supposed to be equal to 0, right? Because it is stated here that the difference, the common difference, is not 0. So we know that our p cannot be 6. So we can actually say that our p is 12. But let me prove it for you guys. If we substitute the p with 12, and we'll have d equals to minus 6. So we're not gonna use this. We're gonna use this, right? So let's say that p is equals to 12. Let's move on to the next question. Using this value, find the sum to infinity of the geometric progression with first two terms p to the power 2 over 6 and 2p minus 6. So first thing off, we already know that our p is equal to 12, right? So let's substitute the p. We'll have the first term is 12 squared over 6, which is 24. And the second term will be 2 multiplied by 12 minus 6. And we'll have 18. And so we know that it is a geometric sequence, right? So we have a common ratio which is equal to the next term, which is 18, divided by the term before, which is 24. And we'll have 3 over 4, which is 0.75. And we know that if r is less than 1, but it is more than -1, then we can use this formula, which is the summation of the geometric progression is equal to a1 open brackets 1 minus r to the power of n close bracket over 1 minus r. Since the r we have here is 0.75, and imagine 0 point something is being, multiplied, keep multiplied 0.75 times 0.75 times 0.75 for like infinity. Imagine that. The answer will be converged to 0, right? This one will be converged to 0. So imagine 1 is being deducted by something that is converging to 0. So like this whole thing would be like 0. Then when n is reaching infinity, we'll have that the summation is equal to a1 multiplied by just 1, right? Over 1 minus r. And that is actually the formula of the summation of the geometric progression when reaching infinity. And given that the r is equals to something that is less than 1 but more than -1, right? So then let's just plug in to get our answers. And we'll have the first term, which is 24 divided by 1 minus 0.75, and we will have 96.